So for this analysis, we started by importing the Python libraries. And for this case, we imported the pandas, numpy, matplotlib, seaborn, as well as the plotly. So I included the plotly library for that will be used for visualization. I saw that plotly is quite good in terms of visualization because it gives you quite control in terms of how you want your charts to appear. The next thing will be loading the dataset. So this is how I imported the dataset onto the Jupyter notebook. So I used the read CSV function. My file is a CSV file. Then I used the .head to display the data frame. Then from that, I moved to the data summary. So I just wanted to have a brief overview or outlook of the data frame. With that, I used the info method from the info method, I got a sneak preview in terms of the data type. So those are the values under the different columns in the data frame. Also, we looked at the columns and the column names, as well as the total number of columns in your data frame, and also the number of entries in each columns. Then from that, we move to data cleaning, and under data cleaning, I checked for duplicates. By that, I used the duplicated method. Then inside the brackets, I used the argument keep equals false. Then I use the sum method so that we can get the summation of all the columns in the data frame that are missing values. And when I executed this cell, we got 0, meaning that our data frame does not contain duplicates. Then from that, we move to checking for missing values. With that, I use the isNull function. Then I wanted to get the sum of all the total sum of missing values in every column in our data frame. And when I execute that, we can see that we are getting zeros. Again, this implies that we don't have missing values in each of our columns in the data frame. Then I moved on to modify the column names. As you can see, column names are quite stretchy. So I just wanted to modify those column names. So with the modification of the column names, I used a dictionary where I supplied the key and the value pair. For example, annual revenue 2022 to 2023, then USD in billions. So I've shortened that to like annual revenue. Then instead of USD in billions, then you just say billions, then use the $sign. So I also did the same to the other columns that I saw were quite lengthy. Also, with the modification of the columns, I used the rename function. So when we execute this, you can see that we have changed those column names, and we have supplied them with the new names. Then from that, we can then move on to the exploratory data analysis. And for the exploratory data analysis, the first thing that we are going to be doing will be the summary statistics. And for the summary statistics, I want to calculate the sum of the annual revenue. Okay, so annual revenue brought in by these companies. Also, I want to determine the sum of the market cap of these companies, as well as the total employee size by these companies, and as well as the total income tax by these companies. So those are the metrics under the summary statistics that I will be calculating. So for the first line of code, we are calculating the annual revenue. So the summation of the annual revenue for these companies. And with this, will be, as you can see, we are targeting the annual revenue column in our data frame, and then we will be summing our result. Then in terms of the market cap, so the summation of the market capitalization of these companies, and the next will be the summation of the total employees. So we are trying to find total number of employees that are employed by these companies. And lastly is the annual income tax paid by these companies. Then after that, we are going to be printing our results. Annual revenue by these companies, you can see that These companies paid a total of 2.5 trillion US dollars. And in terms of market cap, these companies are worth around 12.61 trillion. And in terms of employee size, these companies are employing a total of 4,162,000 employees. And in terms of the annual income tax paid by this company, is totaling to 69.339 billion US dollars. Okay, so that's how you can calculate some of the summary statistics for these companies. Now, the next thing that we are going to be tackling is about the performance of the individual companies. So basically, we are just going to be ranking these companies according to this metric. So as you can see, we are going to be ranking these companies according to the annual revenue, also in terms of the market cap, income tax, employee size, and any other metric that we are going to be deciding. So in terms of the annual revenue, the first thing that we are going to be doing is that we are going to be grouping the data according to the company name and the annual revenue, and we are going to sum. So let's start by grouping the data. So we are grouping in terms of company name and annual revenue. So by this, we are using the group by function, and we are grouping according to the company name as well as the annual revenue generated by the company. Then we are going to sum. Then we are going to reset the index because we are generating a new series of or a new data frame. Print, let's say, the first 10 companies. We can see that though we have sorted our data in a descending order so that we can find the company with the highest amount of annual revenue. So with this line of code, we are sorting the results in a descending order. And by this, we are trying to find the companies with the highest annual revenue. Print these results. You can see that we have now sorted our data in a descending order. And when sorting this, we used the sort values function. Then inside the brackets, we specified we are going to be sorting according to the annual revenue. Then ascending false. So that means we want our data to be sorted in a descending order from the largest to the smallest. Then when we run this, so I've specified I want the top 10. So with the top 10 industries companies, you can see that Amazon is the leading with 513.98 billion, followed by Apple, Alphabet, Microsoft. HP is closing the top 10 companies with an annual revenue of 59.78 billion. We can also find out the bottom companies, let's say the companies from ranked at between 45 and 50, and we are going to use the tail method. So let's say the bottom 5, and when you run this, you can see that amongst the bottom 5 companies, we can now visualize this data. And in terms of visualization, as I had said earlier, I'm going to be using Plotly. For this data, I'm going to create a bar graph. Creating a bar graph to visualize this data. Creating this, so then px.bar. So I'm creating a bar graph, and by px, this I will be referring to the Plotly library. We'll be getting data from the annual revenue data series. Our x value, so the x-axis will be the company name. So this will form our x-axis. And for our y-axis, it will be the annual revenue. So we'll specify the title for our bar graph. Then we can go on and customize the layout. So we can customize the layout. So we want the names of those companies to be at an angle of 45 degrees. So that's the rotation of the x-axis labels. Then we can set the figure size. So I want a width of 1000 pixels and a height of 700 pixels. Then we can display. So this is our plot. So you can see we can now visualize this information. And when we are ranking the top companies by annual revenue, you can see that Amazon is leading, followed by Apple, Alphabet, Microsoft Corporation. Okay, so now you can see how we can visualize this information. We're going to be repeating the same for market capitalization. For market capitalization, I think we're just going to be repeating the same thing. So I'll just copy what we did earlier and just paste it here. So I can just change the name of this variable. Then we are going to be comparing company name instead of annual revenue. We are going to be comparing that to market cap. So this one, you can just correct it here. Then we are going to sum and then reset the index. Again, we are going to sort out our results in a descending order to find the companies with the highest market cap. So we can just again change this. Again, when sorting the values, we are going to be sorting according to the market cap. So we can then display our results. So in terms of market cap, you can see that Apple is the leading at 2.5 trillion US dollars, followed by Microsoft Corporation at 2.037, then Alphabet, that is the Google, at 1.35, then Amazon, Nvidia, Tesla, Meta Platforms, Broadcom, Oracle, then Cisco is closing the top 10 companies in terms of market cap. I want just to go into representing this data using the bar graphs. We are plotting market cap against the company name, and as you can see, this is the plot. Also, as I had said earlier, we are going to be doing this again for the annual income tax. So maybe if you are following through, you can pause at this moment and do the same in terms of the annual income tax. So it's not a different thing. We are just going to be repeating what we have done earlier, but what we are just changing is maybe the names of the variables or the column names that we are going to be targeting. So you can pause just for some time, do it by yourself, and see if we will be getting a similar result at the end. So this is how I did it. So I first started by grouping the data frame. So I grouped the data according to the company name and the annual income tax. Then we sorted the results in a descending order. Then from there we print our results. So I've said the top 7. The top company in terms of annual income tax. So the tax they pay to the authorities. Then we can again plot this data. So again, you can pause for a minute. So for me, this is how I did it. Sorry, on the y-axis is the annual income tax in billions, while on the x-axis is the company names. At the end, towards the right, you can see that some companies are having a negative income tax. For the negatives, I do think companies can have a negative income tax. So lastly, we are going to be grouping in terms of employee size. We are going to be ranking these companies in terms of how many people they are employing. For the employee size, we are again grouping our data according to the company name and the employee size. Then we move on to sorting our data in descending order. Then from here, we are going to print. So in terms of employee size, you can see that Amazon is leading, followed by IBM Corporation. It's employing about 345,000 people. Microsoft is the third, employing 221,000 people. Alphabet, that is Google, it's employing about 190,234 people. Then Apple Inc. closes the top 5 list in terms of employee size at 164,000 people. Then also we can plot this data using bar graphs. We have now represented this data using bar graphs. From the bar graphs, you can see how different companies are ranking in terms of the employee size. We can now conduct another analysis. This will be the geographical analysis. And by this, we are just trying to find out the geographic concentration of these tech companies. Where are we likely to find most of these companies? So that's the main questions. That is the main question that we're going to be answering under this. So let me recall our data frame. So for our data frame, we are trying to determine the headquarters states of these companies. So let's find out how many states we are dealing with. So I'm going to use the unique function. so that it will generate or print out the unique values in the column. When I add when I count the unique values, the total number of unique values in that column, you can see that we have 13 states. Now that we've determined that we have 13 states, now let us group our data and count the number of companies in each state. So I'll just create a variable HQ state. So when we print this, you can see that we are getting the state as well as the count of how many companies are in that state. And as you can see, California is leading. We have 33 of these top 50 tech companies in California, followed by Texas, which has 4. Then Washington and New York are tying at 2. You can plot this data. Again, I will be using bar graphs. So when we run this, you can see that we have plotted the count, so meaning the number of companies in each state. So that's how you can do that. So with this, I've added another element, which is the color. So the bars are having different colors, and I've specified the x-axis, the HQ state. So different bars representing the different states will be having different colors. So the next thing that we're going to be doing will be the sector analysis. Under the sector analysis, we're going to be grouping the different companies according to their different sectors. So we are going to be grouping the data according to the sector and the company name. So with this, again, we're just repeating the same, just as we did earlier. For this, we are grouping according to the sector. So sector, and we are trying to count the number of companies in each sector. So we are using the value counts, reset index, then we print out our output. From the output, you can see that in terms of software application sector, for software applications, we have a total of 15 companies. For semiconductors, we have 14, software infrastructure 12, IT services 3, computer hardware 3, and then consumer electronics, communication equipment, and electronic components. Those sectors have 1 companies each. We can represent this data using a bar graph. So we are going to be plotting a bar graph to represent this information. And we are just going to repeat what we did earlier. So we're just recycling our code. Okay, so this is the output. So as you can see, we have the count versus the state, the sector. And this bar graph is a representation of the number of companies in different sectors. So the next segment will be, we are going to be determining the number of companies founded over the years. I'm going to be using this line of code. So I will explain line by line. So the first line of code is that we are going to be extracting data from the founding year column from our data frame. Then we are going to be counting the number of occurrences of each unique founding year. Okay, by that we are going to be using the value count function. Then from after counting that, we are going to be generating a new data frame. So the results of that data frame are then sorted by year, so that they start in a chronological order. So by that we are using the sort index, so it will sort that data into that order. Then finally we are going to be using the cumulative sum, which calculates the cumulative sum of the counts, giving the cumulative frequency of the companies founded over the years. Okay, then from that we are going to be, since we are generating a new data frame, we are going to be resetting our index. By that we are adding a new numeric index to our column, to our new data frame, and it will be making the founding year as a regular column in our data frame. Okay, so it is counting cumulatively as the years progress by. So now that we have sorted our data, we can then proceed to plot a line graph to represent this information. So we are going to be creating a line plot using Plotly. Our x-axis will be the column founding year. Then our y-axis values will be coming from the column count. Then the titles, cumulative frequency of companies founded over the years. Then we customize the plots. So that means you're going to be inserting some labels, the x-axis and the y-axis labels. So for the x-axis, it will be the year, while the y-axis will be the number of companies. Then we can display our plot. So this is the plot. As you can see, it's a line starting from the year maybe 1890. So as you can see, the number of companies in the top 50 were increasing gradually. So there was a steady rise until around 1969. Then from there we can see there is a big jump in terms of these companies from 1969 up to now, up to 2012. Okay. The first one will be the sector versus annual revenue. So from this analysis, you can see that we have grouped our data according to sector and the annual revenue. Then we sorted the data according to the annual revenue so that we determine which sector is leading in terms of annual revenue. Then we displayed our output. So this is the output, as you can see. In terms of annual revenue, we can see that software infrastructure is leading at with an annual revenue of $822.76 billion, followed by software application, while the least sector is the electronic components at 5.61 billion. Okay, can plot a pie chart to represent this information. Earlier on, we have been using a bar graph, so let's change a little bit to now see how we can plot this data using a pie chart. The first line of code, we have specifying the figure size of our plot. We plot our pie chart. Then our values will be from the annual revenue column. This one, this column will provide our values. The labels will be from the sector. Those will form our labels. Then this is the title of our pie chart. So when we execute this, this is the plot, and as you can see, we have the key on the right hand side, and this is the pie chart. Software infrastructure is contributing about 32.1% of the annual revenues, followed by the software application, which is at 27.8%. The 15% is for the consumer electronics, while as you can see, the list, which is electronic components, in terms of annual revenue, it is contributing about 0.219% of the annual revenues. Okay. So that was about sector and annual revenues. We can also do the same for sector and market cap. Okay, so this is for the sector and market cap. When we are comparing the sector and the market cap, we can see that again software infrastructure is leading. So the total companies under the software infrastructure have a total market cap of 5.294 trillion, followed by the consumer electronics at 2.520 trillion. The least sector, that is the electronic components. So the total market capitalization of the companies under the electronic component sector is 0.046 trillion. Okay, again we can represent this data using a pie chart, and it's just the same thing as we did earlier. So you can just copy this and paste it here and change the values. And as we saw earlier, software infrastructure is leading at 42%. Followed by consumer electronics at 20%, and then software application 17.4%, while the least is the electronic components at 0.365%. We can also do the same in terms of comparing the sector and the employee size. So for this, when you are comparing the sector and the employee size, and if you are following through, you can maybe pause, try it on yourself, compare the two sector and the employee size, and see if we will be getting the similar result. So when we group our data, you can see this. This is the output. So we are comparing sector and employee size. So again, we can see software application is leading with a total of 1.926 million employees. Software infrastructure at 916,800,000 employees. Semiconductors for 464,818. Well, the list again is the electronic components, employing about 19,300 people. Again, we can represent this information using a pie chart. And when we do that, our pie chart will look like this. The sector, software application, is having the highest number of employees, 46.3%, followed by the software infrastructure, which has 22% of the total employees employed by these top 50 companies, followed by the semiconductors at 11.2%, while the least is the electronic components at 0.464%. So with the correlation analysis, we are trying to determine how different metrics are correlating with each other. So for example, is there a direct or an indirect correlation between market capitalization and the annual revenue? So by that we can say if a company has a high market cap, does it mean that it will be paying the highest amount of revenue? So for the correlation analysis, we first have to determine the distribution of data in our columns. Okay, for the distribution of of the data in our columns, I'm going to be using the KDE plots. I'm going to create a list of the columns. For the list of columns, definitely these are the numeric columns in our data frame. So the annual revenue, billions, the market cap, the annual tax, as well as the employee size. So those are the lists. Those are the columns that we are going to be analyzing under the correlation analysis. Then the next thing will be creating the subplots for each column. That means the size of the subplots for each column. Then for this, I'm going to be using the matplotlib Python library. I'm specifying that the columns will be 10, 5. Then since we are plotting the different columns, I will be using a for loop, enumerate. So I'll be using the enumerate function for our subplots. So I'm going to specify 2 rows, 2 columns for the subplots. Then I'm going to use the Seaborn library for while plotting the KDE plots. Then we specify the title. Then we display our output. So these are the KDE plots. And basically from the plots, we want to determine if the values in the column are following a normal distribution. So for the first column, KDE plot for annual revenue in billions. So we are seeing that we are having an irregular distribution of the data. Okay, so we expect that for a regular distribution, we expect that the values to be centered around the mean. But as you can see, our values are slightly skewed to the left-hand side. Okay, and we can also see the same thing is happening for the market cap as well as for the annual income. And you can see the same thing is happening for none of the numeric columns in our data frame are following a normal distribution. So when we are going to be performing the correlation analysis, we are going to be using the non-parametric tests. So we want to be using the parametric tests. For the type of correlation that we're going to be selecting, instead of using the Pearson correlation, so the Pearson correlation will be selecting the Pearson correlation if our data will have been following a normal distribution. But since the case is otherwise, instead of the Pearson correlation, we are going to substitute that for the Spearman correlation. So I'm just going to be using the correlation matrix. So inside the brackets, I'm going to specify the columns that we're going to be targeting. So these are the columns. So basically, these are the numeric columns in our data frame. And since we are doing a correlation analysis, and inside the brackets, I'm going to specify the method. So for this case, our method will be Spearman, which can be used if our data does not follow a normal distribution. So Spearman is a non-parametric type of test analysis. So we are going to display the correlation metrics. So for the correlation metrics, so the first line, this is the figure size. So we want a figure 8x6. Then I'm going to be using the Seaborn Python library and specify that it will be a heat map. So we are going to, and our data will be the correlation matrix, will be from the correlation matrix data frame. Then we are going to annotate the heat map. Then the color map that we're going to be using is the coolworm. Then our results, I want to format to two significant figures. Then we provided the title. Then we display our chart. So this is the correlation heat map, and it's showing the correlations between the different features. So we can use this to show the type of correlations between the different features. So when we compare between the market cap and the annual revenue, you can see that we have a correlation of 0.67. So this is above 0.5, which is, we can say there is a quite correlation between the annual revenue and the market cap. So we can say that is moderately high at 0.67. Annual income and annual revenue, 0.49, 0.5. You can see it's quite at the middle. Also, it's moderate. In terms of employee size and annual revenue, 0.84. You can see also that is quite high. We can see for 0.41 in terms of income tax and market capitalization, there is a 0.41 correlation. Okay, so this is how these features are correlating with each other. The highest is 0.84, which is between the employee size and the annual revenue. Okay, so that's how you can plot such and determine the different correlations between the features. For today, thank you for your time. And before we sign off, please remember to hit that subscribe button, like, comment, and share. And until next time, see you.